All right, welcome to the fourth in a four-part series on cognitively guided instruction. This session is on problem posing and math storytelling in K-5 mathematics. My name is Janice Nowakowski, and I'm the district teacher consultant for K-12 mathematics and numeracy. So what is CGI? Just a quick review for those of you that are joining maybe for the first time along this burst series. CGI stands for Cognitively Guided Instruction, and it's a decades-long sense-making approach to the teaching and learning of number operations. There's various resources and websites that support the work and the research around cognitively guided instruction. Where do we find cognitively guided instruction in our BC mathematics curriculum? The language of CGI is used explicitly in some of the strategies and elaborations. You can see on the screen here, for example, at grade 3, one-step equations with an unknown number using all operations. And then in some of our curricular competencies as well. So problem solving and using multiple strategies to engage in problem solving. One of the aspects of CGI is that there's a hierarchy of strategies that students move through as they learn a new operation and as they work within a new number range. So beginning with direct modeling of the actions or the relationships between the quantities, that may be with materials or with pictures or with students' fingers, tally marks, etc. Counting strategies, whether that's counting by multiples, counting on, counting up, counting down, etc. And then number fact strategies. So that's when they're using facts that they already know to derive new facts or multiply by 10 or divide by 100 and play with numbers in different ways using known number facts. Another aspect of CGI is that there's different problem types. For example, for addition, subtraction, multiplication, and division, there's the result unknown, there's the change unknown, and then there's the start unknown. And depending on the context of the problem, it's a different part or unknown that students are trying to figure out. And those also increase in complexity, result unknown being the easiest accessible structure or problem type, then change unknown, and then start unknown being the most difficult in terms of cognitive steps that a student has to go through. So just making sure that we're presenting students and offering them a balance of those different problem types or structures to support their mathematical thinking about operations. When we think about problem posing and math storytelling specifically, we connect to these three curricular competencies that are across kindergarten through grade 12. So again, develop, demonstrate, and apply mathematical understanding through play, inquiry, and problem solving. Engage in problem solving experiences that are connected to place, story, cultural practices, and perspectives relevant to local First Peoples communities, the local community, and other cultures. And then connect mathematical concepts to each other and to other areas and personal interests. So making math to self, math to world, and math to math connections. So problem posing and math storytelling is an opportunity for students to connect to their own identities, their family, community, cultural identities, as well as things that they're interested in. Their sports or music, or favorite characters and stories, etc. So what is problem posing? We don't hear that term as often as we hear problem solving, but much of the research actually says that problem posing is the highest form of problem solving. So more complex in terms than problem solving itself. And that problem posing is actually much more aligned to the work of what mathematicians actually do, as opposed to problem solving. They pose problems and play with ideas, and then engage in solving and thinking about those problems that they've posed. In secondary mathematics, most of the research around problem posing is playing with the structure and the mathematics of a problem and sort of playing around with that and reconfiguring that. And then what we want to think about is who's doing the problem posing. And again, the research, and most of that comes out of secondary, is that teachers are often the posers of the problems and choosing the context in classrooms. And so for our K-5 students, we really want to offer them the opportunity to see themselves as posers of mathematics and mathematicians and doers of mathematics. So giving them agency around seeing themselves and their lives and their identities connected to what we do in mathematics. So one of the CGI books called Young Children's Mathematics says supporting children to pose problems for themselves as they engage in play or other activities is mathematically productive and often leads to the creation of problems that children care about and understand. And we know that that's an issue for students as they say, why do I need to do this? Or why is this relevant? Or when will I ever use this in my life? And so having them pose the problems, things that are important to them, whether it's about soccer or about, a recipe that they're baking with their family, something that matters to them, they will be more invested in and more likely to engage in the mathematics. So when we think about story as sort of that idea of narrative as a way to engage in problem posing, story is often a really great starting point. And so we're asking students to tell stories and create stories and read stories all the time. And where are those parallels in mathematics? So how does story help support students' mathematical thinking and understanding? Well, story is or narrative is essential to problem solving and problem posing. It makes the mathematics contextual and connected to their lives or the world around them. Story involves action. Something is happening, and that aligns with mathematical structures. Right? So students are able to see that something is separating or joining or combining, or we're grouping things within the story. So the actions in the story reflect the mathematical structures of equations. And then visualization is a really important part of storytelling and story creating. Is what story do we see in our heads? What movie are we playing? And that idea of being able to visualize what's happening is an important part of mathematical thinking as well. So here's an example. Again, these are problems that I actually posed to a kindergarten and grade 1 class. And this would just sort of be that sort of starting point, modeling how we can pose problems that use the children's names in the class or things that they're interested in. And I was in this class during the winter, and we had been working on change unknown type problems, and we were doing them orally. So I told a story of how I had dumplings for dinner last night. And I ate some, and then I talked with my family, and then I ate some more. And then I had them close their eyes, and I had them visualize that story and maybe try and remember a time where they had dumplings or something similar from their culture for dinner or for lunch or for dim sum or whatever it was. And so they've got this sort of story and that movie playing in their mind. And then I added the numbers. So I had 4 dumplings for dinner last night. I ate some more. And then I talked with my family, and then I ate some more, and I had eaten 7 by the end of dinner. So how many more did I eat after I talked with my family? So again, you could give them the structure, you could give them the equation, you could use words and numbers like I have here, and put that on the board. And then we invited students to think about that problem and record it with drawings. And so these are some examples of their stories. And you can see some of them have connected to experiences going out for dim sum and their dumplings, and writing the equations, understanding the commutative property, 3 of 4 makes 7, and so 4 and 3 make 7, and then drawing out how many that they ate in total, and then 4 being the first part. So 3 was the second amount that I ate for dinner. Another example, same class, kindergarten and grade 1, we gave them the choice. So again, a very common CGI structure, if to give students a choice of numbers for the problem. But first, we did it as a numberless problem. We told the story. I made some snowballs. My friends helped me make some more. We counted, and now we have this many snowballs. How many snowballs did my friends help me make? And then I might, again, in this case, we didn't need to, but I might choose one of the number pairs to support the students' thinking and do a bit of an example with that, and then have them choose from the remaining number pairs. But this would be an example. I made 5 snowballs. My friends helped me make some more. We counted, and now we had 9 snowballs. How many snowballs did my friends help me make? And how would we figure that out? So again, the students had a choice. Again, knowing that this was a K-1 class and thinking about the number range that students were working within the class and how they might be able to figure this out. And in this case, these are students that chose the first choice, the 5 and the 9. So they drew them all out. And again, the first part, and then how many more to make 9. And then writing in it in equations as well. So just an example of taking things, again, it had snowed recently. near this school, and so students had snow on the mind. So just taking the students' interests into consideration when you're posing problems and modeling how to do that for the students and how to think about what question is it that we're asking, because that's something that's often difficult for the students. And then thinking about what are those types of math stories that we can tell? Can we tell a counting story? Can we tell a combining or joining story like these ones? Can we tell a removing or separating story, comparing, finding the missing part, grouping stories, fair sharing stories, whatever it is that you're working on in mathematics, what kinds of math stories can we tell related to those concepts? So this is an example, of a table setup, an invitation for students to create math stories. So what math stories can you tell? And whenever I put a little collection together like this, I have little story mats out for them. I have some setting materials, so some trees and some moss and some river. I have some characters, some people and some animals. And then I have some things for them to count or to group or to share. Whatever it is, you need to have some objects as well. So those are sort of the three components. So setting, characters, and then those action items for them to do the math with. So just some more examples of that. Again, they love the little finger puppets and then having some of the equations that they can choose from. And then here, this is in a grade 1 and 2 class. So you can see the different types of CGI structures, change unknowns, start unknowns that students can choose from, and then use that equation to inspire a story or a problem that they might pose. What stories live in these equations? And again, that's something that we talk a lot about with students when it just sort of put that out there and expect them to know what to do with that. So I might have a conversation like this. These are some larger numbers, depending, this would, be grade 3, grade 4. What plus 36 equals 72? 114 subtract what equals 110? What contexts, what stories might you think of when you see those particular numbers and equations? 36 and 72, I think about that relationship with dozens. When I think about 55 times 3, I automatically see 50 times 3 and then 3 times 5. So I decompose. 144, again, we've got 12 12s there. So how can I use that to help me think of a story that might go with these particular equations? So these are some of the prompts. What are you thinking about when you see this equation? What connections are you making? What mathematics do you need to understand to create a story or pose a problem based on these equations? So doing some of that pre-talk and building up of their understanding of what to do when they see an equation like that, to pay attention to the numbers and the relationships between the numbers and how certain numbers also make connections in your life, whether it's sports or music or baking or quantity or age of some sort. So those are some of the prompting questions, sort of building up that idea of what stories might be inspired by particular equations. And then this was in a grade 1, 2 class. And again, a collection of different equations on just cards that they could choose from. So you can use those all year. The students don't write on the cards. They use them. As you can see, they're starting to write their stories. They might draw stories. They might write them out as a narrative. And then here are 2 examples. These were the equations they chose. 18 subtract what equals 12, what plus 6 equals 15. And these, again, this is a 1-2 class, so you can see some of the questions, the problems that they posed. And again, using a really simple structure, there's not a lot of adjectives and adverbs or powerful sentences, but they're writing in a mathematical way that represents the equation, but is written in a narrative form. And then this was an example from a 2-3 class during math workshop. And so we had been practicing addition strategies, and we had done a couple of number talks around that. And then this was one of the many choices during math workshop. So there was some addition practice games. There was an app on a small group of iPads out at one table. There were some puzzle games. And then this was one of the choices, and just all it was the equation cards and then the little whiteboards and markers for students to solve the equation and then think about a problem and pose a problem that goes with that. Another example where this was the whole lesson. So we did this as a whole lesson. This was in a grade 1, 2 class. And again, students chose different equations. You could do this for multiplication or division, whatever it is that you're working on. And then they built their stories around this. So you can see on the bottom right, 46 and 28. This class was studying salmon at the time. And this was the student's problem that they posed. The salmon was swimming up the creek to spawn and then laid some eggs. The salmon laid 46 eggs in a red and then another 28 on the other side of the creek. And then it swam away and laid 1,000 more. How many eggs did the salmon lay? So you can see the student has used the equation and then they've added the extra 1,000 in. Maybe if it was a number like 543, that might be beyond their reach, but adding 1,000 to an existing amount would be doable for this student. And they've integrated all their knowledge that they've been learning about salmon into the math problem that they've posed. So just an example of where that idea of math story and bringing children's interests and knowledge, background knowledge, into an opportunity for them to make connections to mathematics. This is another example from a grade 2-3 class where after students had posed their problems, we typed them out. And then those were just in a basket that students could choose from as one of their practice tasks. They could choose each other's problems to solve. And you can see on the top right, pairs were working together and they were using different strategies to solve different problems and record them. And then again, on the bottom right, the student had chose a problem about Beanie Babies, stuffed little stuffies, and then was using, concrete materials to access the quantities in that particular problem. Whereas other students were working on open number lines and mental math strategies, but all students could access them using different strategies and different tools that were available to them. And they love solving each other's problems, especially when they have each other's names in them. And then this was just an example from today. I was in a grade 3-4 class and we were doing a math workshop again. We were working on subtraction strategies. And so this was one of the tables where they could choose a question and then what math story can you tell, draw, or create to show that you understand the question or the process of what's happening. And we had talked in this class about how subtraction isn't just about takeaway, it's about looking for the difference or comparing the difference. So I wanted them to practice those two ideas. And all of these questions, for those of you who have been on RichNet, if you go to Learn 38 and you go to the grade level framework, K-2 or 3-5 or 6 and 7, and you go down below that, there's practice questions. And they're all from transitional learning and they've all been compiled. And I just copied and pasted them and printed them out on cards so that students could use those all year long as practice questions. And that's just an example from today in the grade 3-4 class. So again, this is where you find all the mathematics and numeracy resources on RichNet. And then this is where those math practice questions are underneath the framework. These are the extra tiles, so math concepts and practice questions. Those are there, as well as there's an extra CGI math resource page as well, with some of those equation cards that you can print out and some background material and resources on CGI. So as we come to the end of this 4-part series, I invite you to think about what can CGI offer as an approach to teaching to the diversity of students in our classrooms. What can you learn about your students from the problems they pose or the math stories they create? And what opportunities can CGI offer as a way for students to have agency over their own mathematics learning? Thank you for joining me.